Okay, so I just recorded a whole video about compound interest before noticing that my audio was not working. So I'm going to go back through what I wrote and narrate this whole thing for you. Okay, so let's start over. In the last video, we talked about the simple interest formula, which is this right here. But that's not always how interest works. A lot of times, if you have some bank account, you will earn interest in that bank account, say every single month. And every single month, that interest goes into the bank account and starts earning interest of its own. In other words, that interest starts compounding. And for situations like this, we have a totally different formula. It's called the compound interest formula, and it looks like this right here. Now you'll notice it has some similar letters in it to the simple interest formula. The principle is still the same. It's the initial loan amount or the initial investment amount. The R is still the interest rate, except this time R is always measured annually in this formula. T still represents time, but since our interest rate is annual, our time is always going to be measured in years for this formula. N represents the number of times interest is compounded per year. So as an example, if we're compounding interest monthly, that would mean N is 12 because we're compounding interest 12 times per year. A in this formula represents the total amount of money in the account, and it looks like I had a typo there, after T years. Okay, let's use this formula in the following example. Let's calculate the total amount of money in this account, given that we're initially investing $4,000 at 3 years, 7% interest compounded semi-annually. Now, semi-annually means twice per year. What that gives us is that we're compounding our interest 2 times per year. In other words, N equals 2. Our initial investment is $4,000, so P equals 4,000. We're doing this for T equals 3 years, and a 7% interest rate means that our R value is 0.07. Now, what we can do is take all of those values and plug them into this formula over here, and I'm going to show you how to type that into your calculator. We're going to put in 4,000, then in parentheses, we're going to have 1 plus 0.07 divided by 2, and we're going to take that thing in parentheses and we're going to raise it to the 2 times 3 power. Now, you could just put the 6th power here, because you know what 2 times 3 is. But if you have two big numbers here and you don't know how to multiply them in your head, what you want to do is you want to put a parenthesis and then 2 times 3 and end those parentheses. Those parentheses are important right here and right here. If you don't put those parentheses in, what your calculator is going to think is it's going to want to raise this thing right here to the 2nd power, and then it's going to take this whole number and it's going to multiply that entire number by 3. That's not what you want to do. You want this 3 to be in the exponent. So, okay, we're going to hit enter on that, and we get that $4,917.02 in the account. So you can see that we started with $4,000, and we ended with $4,917.02. So while the total amount of money in the account is this $4,917.02, the amount of interest earned we can calculate by subtracting from that the initial amount that you invested. That gives us that we earned $917.02 in interest, and I think we're ready to try the next problem. This time we're going to use the compound interest formula to compute the total amount accumulated and the interest earned using $1 over 1 year at 8.7% interest compounded monthly. Again, here is our compound interest formula. We're going to plug in a $1 investment for 1 year. Those numbers might seem strange, but there's a method to the madness. We'll talk about that in a second. Our interest rate is 0.087, and because we're compounding monthly or 12 times per year, that gives us N equals 12. So we can take all of those values, plug them all into our compound interest formula, and we need to plug all of that into our calculator. So what we're going to do is we're going to start with a 1. We don't really need to put that outside the parentheses, but I will this time. And then inside the parentheses, we're going to have a 1 plus 0.087 divided by 12, and all of that is going to be raised to the 12 times 1 power, which you could call 12 times 1, or you could just call 12 up there. Either way, if we hit enter on this thing, our calculator gives us 1.091 if we round to 3 decimal places. And what that means is if we start with a $1 investment, under these terms, we're going to end up with $1 and I guess 9.1 cents at the end of that year. That means that we earned a total amount of interest of 9.1 cents or 0.091. Now, the reason that we used P equals 1 and T equals 1 in this problem is because when we do that, the amount of interest that we earn is going to actually give us the simple interest rate that would earn us that same amount of money over the course of that that year. The reason is written up here in this little thought bubble. If we took the simple interest formula and plugged in P equals 1 and T equals 1, we would just get the amount of interest earned is the interest rate itself. So having gotten this 0.091 interest earned is the amount of interest that would have been earned in a simple interest account at 9.1%. So that 8.7% interest compounded monthly effectively gave us an annual yield of 9.1%. We also call that the annual percentage yield, which you may have seen before as APY on an account. Again, this 8.7% interest compounded monthly gives us an APY of 9.1%. Now let's look at this next problem. A bank tells us that they have a 6.4% interest rate compounded monthly, and they're telling us that that is a 6.7% APY. There's a problem with this. So if we're trying to find or investigate this APY, what we're always going to do is choose a principal of $1 and a time period of 1 year. We're going to take that 6.4% interest rate compounded monthly, which is n equals 12. We're going to plug all of that into our compound interest formula, and that looks like this. And when we do that, we get that the total amount of money in our account is 1.0659, rounded to 4 decimal places. Now, knowing what we know from doing that last problem, we can read right off the bat that our APY for this 6.4% rate compounded monthly is actually 6.6%. So this bank is wrong. They're advertising a 6.7% APY. The actual APY is 6.6%. All right, let's take a look at one more problem here. This is going to be a colorful one. They're turning things around on us a little bit. They're asking how much money needs to be invested now in order to pay off $80,000 13 years down the road at 6.9% interest compounded monthly. Now the thing to notice about this problem right off the bat is that this $80,000 is not how much money we're investing into an account. It's how much money we want to have in the account after 13 years. So this $80,000 is not P, our initial investment. It's A, the amount that we want in the account after 13 years. So they've given us $80,000 is A. They also give us R is 0.69, T is 13, and N is 12 because we're compounding monthly again. If we plug all of those values into our compound interest formula, we get this right here. And you'll notice that P is the unknown in this problem. And I think that makes sense because we're trying to find the amount of principal that we need to put into this account to have $80,000 at the end of 13 years. So we need to solve for P. To do that, you may have seen earlier that what we need to do is divide both sides of the equation by this big messy expression next to P. If we do that, on the right side of the equation, we just end up getting P by itself. On the left side of the equation, we end up getting what we have to type into our calculator, 80,000 divided by that big messy expression. If we do that, we end up actually getting $32,707.21. But let me show you how to plug that into your calculator. We're going to do 80,000. We're going to divide by 1 plus 0.069 divided by 12. And we're going to raise that whole thing to the 12 times 13 power. The 12 times 13 again, we need to put into parentheses. Okay, when we do that, our calculator spits out that number that I gave you. So what that says is that if we invest $32,707.21 into an account now, after 13 years, we're going to have $80,000 in that account. Now, we have a name for this. If we're wondering how much money we need now in order to have some fixed amount of money that we're looking for in the future, we call that current amount of money the present value. And you can find the present value for any of these problems just using the compound interest formula. Or what you can do is you can take this compound interest formula, and before plugging any numbers into it, you can divide both sides of the equation by this messy expression, 1 plus R over N to the NT power. We can do that right down here. And you'll notice if we divide both sides by that messy expression, you just get P by itself on the right side of the equation. And on the left side of the equation, you're left with A over that messy expression. Now, a lot of textbooks do this, and they give this to you as a separate formula. It's called the present value formula. Feel free to use it, but keep in mind that it is really just the compound interest formula rewritten in a different form. Okay, I'm sorry that that video was a little bit different than normal. Usually you watch the expressions and the equations going up as I talk, but technical difficulties with the audio on my end. I apologize for that. Hopefully this video still helps you out, and we'll go back to normal in the next one. I will see you all there.